Okay, welcome back. In the last video, we calculated a fairly large adjoint of a 3x3 matrix. Now we're going to go back to a 2x2 and we're going to do something with our adjoint calculation. So the first part, we're given this 2x2 matrix and just asked to find the adjoint. So let's go ahead and do that. So first step is to transpose it. So A transpose is equal to first row becomes first column, second row becomes second column. Now step 2 is we're going to calculate the cofactors of A transpose. Oh, I almost forgot to unerase this for the previous example there. Okay. I'm going to just hide this so I don't accidentally use it in the calculation. So we have C12, or C11 is equal to -1 power 1 plus 1 times the determinant of 4, 5, 2, 5. We eliminate row 1, column 1. We just have -1 squared times the determinant of 5, which is 5. 1 times 5. So we get 5 from that. Now C12, so -1 to the 1 plus 2 times the determinant of, I'll make a copy of the matrix, 4, 5, 2, 5. This time we're crossing out row 1, column 2, and we just have -1 cubed, which is -1 times the determinant of 2. So times 2, we get -2 for that one. Then C21, -1 to the 2 plus 1 times the determinant of, make a copy, 4, 5, 2, 4, well, 4, 5, 2, 5. This time we're crossing out row 2, column 1. So we have -1 times 5, which is -5. And now the last entry, C22, -1 to the 2 plus 2 times the determinant of 4, 5, 2, 5. We're crossing out for that submatrix. We're crossing out row 2, column 2. So we'll have +1 times 4, which is 4. And then we can put all this stuff together to say that the adjoint of A is equal to 5, -2, -5, 4. And I'll unhide A. Okay, now part B. Let's do what it's asking us to do. It's asking us to take adjoint of A and multiply it by A. So this is going to be 4, 2, 5, 5 multiplied by what we found for, it's okay. I'll do it this way. Adjoint of A, 5, -2, -5, 4 multiplied by A, which is 4, 2, 5, 5. And now we'll do those multiplications. So the first entry, in the top left, we do dot product between row 1, column 1. So 20 minus 10. And then we have the next entry to at the top right is row 1 dot column 2. So we'll have 10 minus 10. Bottom left entry is the second row dot product first column. So -20 plus 20. And then last is row 2 dot column 2. So -10 plus 20. And what we get is we get 10, 0, 0, 10. Now the next part's asking us to reverse the order of multiplication. Instead of adjoint of a times a, it's asking for a multiplied by the adjoint of a. So that's okay. We're just going to redo this calculation. 4255 multiplied by adjoint of a, 5, negative 2, negative 5, 4. So we'll do the dot products. Row 1 dot column 1, 20 minus 10. Row 2 dot column 2, negative 8 plus 8. Then row 2 dot column 1, 25 minus 25. And then row 2 dot column 2, negative 10 plus 20. And we get 10, 0, 0, 10. Okay, now in part D, find the determinant of A. So this is the determinant of the original matrix, 4, 2, 5, 5, which is down product 4 times 5 minus up product 5 times 2. So 20 minus 10, we get 10. Okay, so that's the final answer for that. Now what? We did part A, B, C. Now there's a part E. Show that A inverse is 1 over the determinant of A times the adjoint of A. So this is what we need to do in order to show this. We need to show that A inverse is equal to identity. And that would mean, in this case, that A times 1 over the determinant of A times the adjoint of A is equal to the identity, and A inverse times A is equal to the identity, which would mean 1 over the determinant of A times the adjoint of A times A is equal to the identity matrix. We need to show both of those things in order to show that this new matrix is the identity matrix, or that this new matrix is the inverse matrix. So let's do the first order. A times 1 over the determinant of A times the adjoint of A. We can use a matrix multiplication property that 1 over the determinant of A is a scalar. And we can bring a scalar in that multiplication out front. So 1 over determinant of A comes out front. And then we have that is multiplied by A times the adjoint of A. Now we already did A times the adjoint of A, and we already found the determinant. We found the determinant was 10, so 1 over 10. And we found A times adjoint of A was 10, 0, 10, 0, 10. 10, 0, 0, 10. And multiply 1 over 10 through, we get 1, 0, 0, 1 as needed. Now we have to do the other order. So, and now we have the other one, 1 over the determinant of A times adjoint of A times A. is equal to 1 over 10. We already did adjoint of A times A. 10, 0, 0, 10 from the previous slide. And that simplifies to 1, 0, 0, 1 as needed. Thus, A inverse is equal to 1 over the determinant of A times the adjoint of A. So calculating the adjoint gives us a way to calculate the inverse without any row reduction. It requires us to do a bunch of determinants in order to do our cofactors. So now it's turned into a balancing act of two different strategies. Would you rather do cofactor calculations or row reduction calculations in order to find the inverse? And it may depend on the details of the original matrix. How many zeros are in there? How close to being fully row reduced is it? If it's really close to being row reduced in any matrix, row reduction is probably a little bit of a better idea. But if you look at it, you can tell right away that there's going to be tons of fractions. This way is probably going to be faster, or at least less unpleasant. And yes, it will always work as long as the determinant is non-zero, which is not surprising because if the determinant is 0, there's no inverse. The formula is telling us that fact as well. So, quick example. Find A inverse if we're told that A is a 2 by 2 matrix, the determinant of A is negative 50, and the adjoint of A is the matrix that's given there. So this is just a formula question. A inverse is equal to 1 over the determinant of A times the adjoint of A. So 1 over negative 50 times the matrix that's given, 20, negative 15, negative 10, 5. We're going to multiply that scalar into every entry of the matrix. So I'll have 20 divided by negative 50, negative 15 divided by negative 50, negative 10 divided by negative 50, and positive 5 divided by negative 50, which each simplifies. We get negative 2 over 5, canceling the 10s. Then the next one, we cancel the 5s, negative 3 over, or positive 3 over 10, the negatives cancel. Next one, positive 1 over 5, the negatives cancel, we cancel the 10s, and then cancel the 5s in the last one, minus 1 over 10. So we didn't need to do any work, not really, not a lot of work. We were given the adjoint, we were given the determinant, we just had to combine them using the formula to find the inverse. All right, here's another similar in spirit example to that one. We're given the inverse. We're given the determinant, and we're asked for the adjoint. So we start with the formula that A inverse is 1 divided by the determinant of A times the adjoint of A. And now we're going to cross multiply. We're going to isolate for the adjoint of A, since that's what we're after. We're going to isolate, we're going to rearrange so the adjoint of A is equal to the ingredients we're given, multiplied by each other. So cross multiply. And we'll get adjoint of A is equal to the determinant of A multiplied by A inverse. So the determinant of A is given to us in the question as 10. A inverse is given to us in the question. 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1, 0. And we just multiply each of those entries by the scalar, multiply them each by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 70, 60, 50, 40, 30, 20, 10, and then 0 times 10 is just 0. That's it. That's all we have to do. So it's a formula problem. You answer it by rearranging the formula. It could also be asked to find the 3-2 entry. Find the 3-2 entry of the adjoint of A. Well, then the 3-2 entry is just going to be row 3, column 2, 60. All right, let's continue in this problem in the next video because it's going to take more than 4 minutes.